Alright, sports fans, we're talking about 6-6 solving exponential equations. Whoa, I didn't mean to do that. Well, we can solve 3 to the x equals 15 with a graph. Not my favorite way of doing it, but definitely can do that. We go under calculators under y1 and we type in 3 to the x. Under y2, we type in 15. So if we would do that, go in there. Make sure there's no plots turned on. You don't want any of these plots turned on. If you need to, go into second stat and make sure that they're all shut off. Um, that's always good. Let's see, y equals, we've got 3 to the x power. Blinding. Let's see here. Then we've got y to the second one is 15. We'll go to zoom 6. Zoom 6, and that gives you that window. But you'll notice that y equals 15 isn't on that graph. That's because it's above the graph. We need to expand our y values, maybe go up to a high y value of 20. Then take a look at our graph. We'll see our 3 to the x here in a second, and then we'll be able to see our y. Now we want to find where those things cross. So we'll go to second, calculates above the trace button, and then we can calculate number 5, the intersection. When we use number 5, it asks us, is the first curve y equals 3 to the x? And I'm going to say yes by hitting the enter button. Then it's going to ask me if the second curve is y sub... Can you even see that on screen? Maybe I can't see that on screen. Second curve is y equals 15. I answer yes by hitting the enter button. It asks me if I want to guess. I do not want to guess. I'm just going to hit the enter button. I would only need to guess if there were multiple intersection values on the same screen. But we only have one, so we don't have to worry about it. So the answer is 2.465 approximately. 2.465. So this location, 2.465. So 3 to the 2.465 power is approximately equal to 15. Now, I want to see logs. Not graphing calculators, but logs. So what I'm going to do, and I had a really good joke for that, but I thought it was inappropriate and disgusting, so I will continue on. We want to change this to its logarithmic form. Log base 3 of 15 equals x. Log base 3 of 15 equals x. So that's what I would do. Now, the theorem that we're going to talk about actually at the end of this lesson comes in real handy right now. Now, I know your other algebra 2 teachers probably wanted you to take the log of both sides and move the exponent down in front. Yeah, that works. You want to take the base 10 logarithm of both sides. Move the exponent down in front based upon that property of logarithms, and then divide by that number, log 3. Sure, that works. That gets us to the same place. But, do you realize we could use the change of base theorem? Now, I'll go through it more carefully here in a little bit, but it's the log of the argument over the log of the old base. And you get to pick whatever base you want. I'm going to choose base 10 because my calculator does base 10. So this is how I'm going to get the 2.465 number. Yes, I'd have to use a calculator for that. I just don't know that in my head. Okay, example 2. Using the continuous change model. That's the Pert formula. In 1995, they measured the population of Mexico at 94 million people. The rate of growth they said was 1.9%. That translates into an R value for our formula of 0.019 because you have to change it to a decimal. The question is, when will it reach 110 million? People want to know that kind of thing so they can start planning ahead, building roads, putting in water lines, all kinds of stuff. So if they know when that needs to happen, then they can plan for those things. Otherwise, you have a mess. Well, let's see here. I know how much I started with. I know my interest or my rate of growth, and I know my target where I want to figure out to. I just don't know the time. So we're going to divide by the 94 million. Yes, we are dealing in millions, so I don't have to worry about putting all those zeros in. 110 divided by 94. Okay, 1.17 approximately. So 1.17 is approximately equal to e to the 0.019t. Okay, time to change it into its log form. What's the base? That's right, e. So we use natural log of 1.17 equals, or is approximately equal to, 0.019t. Last but not least, divide by 0.019 and we are done with this question. Save for a little bit of typing. Natural log 1.17 n parenthesis divided by 0.01. 8.26 years. Well, what about that Pert formula? Can't we use the Pert formula for half-life? Well, you can. The book does show you examples of that, but it's really confusing and I don't like it. So I'm not going to use it. I'm going to use the good old half-life formula we used in Algebra 2. So let's see here. We know that this is the starting amount. We know that our growth factor is always 0.5. That's why it's called a half-life. Please know that. Don't make me look at you on a quiz or a test. I really hate to look at kids that don't know what the growth factor is for a half-life question. You have an exponent, which is a fraction, and it has x over the half-life period. Now, it doesn't stand for help. The half-life, let's suppose the half-life in example 3 of carbon-14 is 5,730 years. How old is, they used a skull, if 63% of the carbon-14 remains? Well, let's see here. So we have our growth factor, 0.5. We know our half-life period, 5,730 years. We know how much is remaining now. What percent did we start with? What percentage did we start with? Well, the answer is always 100%. We always start with 100%. And the decimal equivalent of 100% is 1. Now, did I need to write that 1 in there? Absolutely not. And if any of you start this problem out by dividing by 1, we are in trouble. So, what do we need to do? Change it to its log form. Well, the base here is 0.5. And the argument, 0.63. And it equals x over 5,730. Remember, I told you if you can't solve it in its exponential form, change it to its log form. Now, I don't know about you, but I'm going to practice using that change of base theorem, which says the log of the argument over the log of the old base. Now, how do you solve a proportion? That's right, cross multiply. X equals 5,730 log 0.63 over log 0.5. Do not attempt to cancel the logs like there's some kind of variable or something. No way, man. Who would do such a thing? Trust me, I've seen it done. 5,730 times the log of 0.63 and parenthesis, that's important right there, divided by log 0.5. And it ends up being 3819.48 years. Okay. Don't ask me why. I should have thought of this myself. But they finally decided to show you the change of base theorem at the end of this section. So, just as a refresher to you, since we pretty much already know how to use it, you don't understand how to deal with a particular log, you can always change it into the quotient of two separate logarithms. And I always say the log of the argument over the log of the old base. And the cool thing is you get to choose whatever base you want for the new logarithms. Now, why do we choose base 10 or base e? Sorry for the half yawn. Don't hurt me in class. Well, that's because our calculator can do that, okay? It's a calculator issue. Those two bases are programmed into your calculator. So that's why we choose 10 and e. So in example 4, which is not unlike some of the other examples we've seen, we have this situation. I have no idea what power on 4 gets me 150. 150 and 4 don't share a common base. I know 4 has a 2, but 150 doesn't. So can't use that idea. I must change this using logarithms. Now, it would not matter if I did it with base 10 or base e. Both of those would give me the same result. In fact, you try the first one and I'll try the second one. Natural log 150 in parentheses divided by natural log 4. And I got 3.614. Just for fun, I'll show you that it's the same exact thing. So, doesn't matter whether you choose base 10 or base e, you'll get the same result. If you want to double check your work, always keep in mind this is the same thing as saying 4 to the x equals 150. So how can I use that to double check my work? Well, I can say 4 to the answer. Hopefully you know how to use the answer feature, which is right above the negative sign. When you do that, you better get 150. And we did. So that's a good way to check it. See you in class.